everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Neil, who has completed the course ROS 2 Navigation in 5 days. And at the end of this course, you can present a project, which is what we're going to see here, implemented on a real robot here at the construct. Hello, Neil. How are you?
I'm good. How are you?
I'm great. I'm very excited to see what you've done for your presentation. So whenever you want, please share your screen and start telling us how you've done your project.
Yes.
Okay, we can see your screen now.
Is the screen visible? Okay. Yes. So should I initiate everything and get the robot moving? Open up the ROS first.
Yes, if we can see the application on the real robot and you can sort of explain how you've achieved it, that would be great.
Yeah. So the goal of this project is to basically create a navigation stack
Mm-hmm.
and give certain points on this map, on this circuit that has been that is present here, and give it certain points so that it can travel to those points which have been given through a Python script. So I will just start my localization service first. So now I'll give it the 2D pose estimate so that the robot has an idea as to where it is.
Mm-hmm.
It looks like it must be over here.
Yeah, it's right there.
Is in this spot.
Yeah.
I think I will turn it a little bit, turn it around a little bit so that the point cluster concentrates to a point or has like a fairly
Mm-hmm.
good idea. So you can see that now the walls are more or less coinciding with the laser scan as it was not before.
Mm-hmm. That's
Okay,
good enough.
yeah. So now that we have the localization done, we can start with the path planner. So now the uh, map has completely lit up, showing that the cost maps are active.
Uh-huh.
I will turn it the scan to maps so that we can see the robot a little more clearly. Okay. So now that the path planner is active, I will give it points that have been labeled previously by me in a YAML file.
Uh-huh.
So, so I gave it corner one, which is this one. Okay, so point one is corner one is this point. The next point I'll give is corner two, which
Uh,
will be over here towards the northwest corner, and
okay.
then the last point I'll give is towards this zebra crossing, this pedestrian crossing.
All right. So you're running a node and then
This
giving it an executable,
it's
a parameter file, I'm sorry. Okay.
yes, Okay, so it has basically gone right through it, which is supposed to go around it. This is a problem I faced because apparently the cost maps, even after I am reducing the uh, or increasing the cost map radius and decreasing the decay, still like the inflation layer is not making the robot to go around the obstacle for some reason. Maybe because like the spikes on the obstacles are really thin, maybe it's not identifying it, but it
Yeah,
more or less.
I think there are two things here. Um, so the first thing that jumped out at me was your cost maps in Arvis here. So, which is um, so one of them. You were saying the cost maps. Which one do you mean? Because there's two, right?
Yeah, so the global cost map
Uh huh.
is the same, right? But like the local cost map should be updating, and then based on that should go around the obstacle because as soon as it sees or identifies the
Right.
obstacle, it
Right.
should, but
So
it isn't updating.
what jumped out at me was that uh, I don't know if it was the local. It seemed like it was. It was like a giant purple line, sort of on top. So can we here in Arvis? You can actually deactivate one of the cost maps. Do you have two in there? Do you have?
Yeah, global as well as local. So if
L-
I
yeah.
turn off,
Let's remove one. Seems like Arvis is having trouble to update that. Uh,
should I turn this to cost map, the
yeah,
colors
so usually the global cost map is set as map and the local cost map is set as cost map. So yes.
cost map, right?
So
Yeah,
here,
so
that is something that jumps out at me as being misconfigured here, because usually the cost map uh, is smaller than this. It seems like you see. It seems like it's been sort of
it's
expanded or something and then flipped, and you can see that it takes up the whole
yeah,
map. So that's definitely one issue. I'm glad that you can see the cost maps because I know there's sometimes an issue with remote connections and cost maps. But this is definitely one issue. But now this is a different thing from the global cost map. So if we could turn off this local cost map and turn on
okay.
the global one. Aha. I think you would have to relaunch everything so we can visualize it. But anyways, what you were saying here, what you were saying is that uh,
Like
those obstacles would have an inflation layer, right?
yeah, exactly. And it did have it previously when I was testing the robot. Like these points that are marked black, they had like a proper inflation layer. So sometimes they would go around, but sometimes they would go right through the obstacles.
So it has to have a global cost map. Otherwise, your navigation stack would not run. It would just
Will fail.
error out.
Yes.
The local cost map is another story because it's like an extra thing you can put on the stack to avoid dynamic obstacles. So, yes, it seems like for some reason it didn't take into account the whole the cost map. So that's why we saw it run into it directly. So, can we just with this Arvis configuration, just like as is, could we just close the path planner and then run it again? So just the terminal where you did, yeah, this one exactly. Maybe we'll see again the cost map. Doesn't look like it. And what if you send it a goal now, just manually or whatever you want?
Okay.
Yeah, yeah,
Via goalpost?
yeah, yeah.
Okay.
So
Over here.
you see the robot right now, it's not taking into account the dynamic obstacles that weren't in your uh were there,
Yeah,
so that's
so
why it was running. But see how it's still going around it. So in this path, it's already taken into account those obstacles because otherwise the path would not be going around it.
Around
It
it.
would just be going through it. So in here I see another thing that tells me that the cost maps are actually there. Again, they have to in order to nav2 to work. This is a visualization issue that is not your fault. It's basically our vis's issue.
But
Uh,
it's right now going into some kind of recovery behavior, right?
yeah, so if you go to your terminal, yeah, you'll see that, passing new path. No, it's not yet in the recovery. It's just sending new paths that it's finding. Uh, so as soon as you run into recovery, you would see, recovery attempted, spin, or backup. So we would see that actually if you actually open up
Uh,
your controller realm, I believe it is. Oh no, the recovery. I'm sorry. Yeah. So this is where they would turn on, but
yeah, but it isn't showing up right now.
no,
It's
no.
just saying that. I think it's stuck because of all the obstacles around,
It would still
but
be
it's
be
still
able to.
looking for a new path.
Mm-hmm. Mm-hmm. So uh, there's definitely something that is misconfigured here. But yeah, if you want to, yeah, that's right. So you can see that it's gonna go and try to do that. But my guess is right now it's on top of that cost map. So you would need to move it manually out of that location. So like kind of get it in the middle of the two lanes there. Yeah. And then if you try, now we should have the movement. It's going to run into those other two, but at least we have the initial movement. We'll see. Yes, you see? So it now kind of fixes itself. It kind of froze that camera there a little bit. But here, now it's getting stuck, right? So
Okay.
at this point, this is actually
Okay.
encouraging. Oh no.
Pose goes off grid, it's saying.
Yeah. Okay.
I think I'll try it again as I've seen this happen with him.
Well, yeah, sometimes it will work, sometimes it won't. But at this point, this tells me here that your local controller is actually not working, right? It's not turned on. Otherwise, it would see that and would go around it. Uh, so,
Yes, exactly.
so yes, that is what is going on in there. So, I'm sorry to interrupt. I was just wanting to go through these steps with you, sort of to understand what is going on. Could you a little bit explain us what you did there with the labels where you ran
Oh,
a program and with a corner or a pedestrian and it went there? Could you explain us that part, please?
yes, I will start with showing you the script. Spots to fight. Yes. Yes. So, what there are actually two methods shown in the notebook that
Uh
I could
huh.
either use the AMCL pose or the initial pose. I went with the AMCL pose because I felt like having the AMCL pose would be more accurate and also a little bit easier.
Mm-hmm.
So initially, I created a server that saves the spot with this name, and then and it saves it to the spots.yaml file in the project localization config.
Hmm.
So with this, uh, after some pose is detected, after the path planner server is turned on, no, the localization server is turned on. After some pose is detected, I give it a label. As long as the label is not end, so if it's corner one, it goes into this block, else block, where it adds all the
Yeah.
pose data as well as the orientation data,
Hmm.
and it adds it, and I can keep on doing it like for multiple iterations, like corner one, corner two, corner three, corner four. But I stopped at three, and
Mm-hmm.
after the third one is done, I click end. So after uh, I write end. After I type in end, it adds all the data to the YAML file that is over here.
Nice.
And so we use a YAML file because it is then easier for us to access and use the data in the YAML file to give to navigation pose. I will show where I leave it over.
Right. So that's the program to save the spots. Now you must have a client.
Yes. Yes. So this is go to pose.
Uh huh.
This is an action client. So while uh, the other things are going on, we need to use the data from the YAML file and give it to the robot so that it can travel to that position. It is like replacing the goal to pose, but with a program.
Yeah.
This 2D pose, but with data given programmatically.
Mm-hmm.
So now, based on the parameter I give, so if I give corner one, it enters all the positional values,
Oh, nice.
and corner two, all the position values, and pedestrian these values. And in case none of these labels are there, it says that there is an invalid label. I could have also gone with another method where I basically have this part um, set as a string, so that whatever label is given, it can directly put in as a string,
Hmm.
so that I can have more labels added. Here it just confines the um, number of labels that can be used only to three. That is a change that I could make.
I see. I see. Nice. And then you
So
actually send that goal with
standard.
those
Yes.
parameters. Nice. Awesome. This is really
Yes.
really nice, Neil. Could we actually try one thing, because I'm actually really curious, and it's to try this on the simulation. So we would need to see if there's any differences between the real robot and this. Well, my first question is this behavior the same in the real robot and in the simulation?
No. While I was testing my robot, I had no problems with the simulation, but we can still test it out right now.
Yeah, could we actually do that?
Yeah.
So all you need to do is disconnect from the robot first to make sure there's no conflicts there. And I think you will lose your terminals, unfortunately. But then we can
Yeah.
launch the sim and just do the same thing. And then we will be able to see those cost max because everything's local now. You can close the, yeah, great. So first you would need to launch the simulation. That's the only extra thing.
Yeah.
And oh, you have it. Nice, nice. You actually have to source. I forget which workspace it is. There we go. I like your speed. That means you have been practicing a lot with this. Always good to see.
I've done this many times and failed, so I know. So that's why I have it in this notepad right here.
I should re-say it. Not speed, but familiarity. You could go slow and it would still be fine. All right, great. So I think, yeah, once Arvis opens up, it's gonna take a little while. Try actually closing Arvis and running it again. Control C it and
Okay.
just Arvis though. Hmm.
It's getting stuck here. Should I restart the terminal? I'll just close everything and maybe
Uh,
then
yeah, I mean, yeah, now you lost your. Start with Arvis first. I don't know, maybe something went wrong in here. So my last thing would be to ask you to actually refresh this page,
oh,
which is the whole uh, website. Maybe something went wrong, a moment of disconnection there. All right, so while this loads, let me actually mention a couple things that I really liked about your project. And it's first of all, the way you save those spots and then read them afterwards. So I really like to see that there is a parameters, ROS2 parameters, and not just a text file. So that's something I would really liked because it's going to be really useful down the line. So I wanna just mention that real quick while this loads up. Okay, now you should be able to. I mean, don't know why this opened up, but Arvis should work now.
I'll start it. Should I start with gazebo right first?
It doesn't matter. Yeah, it doesn't matter really. There. Okay,
Yeah, it's okay.
good. Yeah, it was something that was getting stuck. Just make sure you source it too, because this won't work. All right, we can leave it there. Now let's go back to Arvis, and we should see. I mean, once you load the config. Mm-hmm. Great. So once we launch these path planners, we'll be able to compare those cost maps that were giving issues. Yeah, that should be it. Okay, great. So that's still a problem with the local cost maps. So then
The
that
line.
means this was running fine and everything was finding its place because there's no dynamic nothing in here because every time you run up the simulation, they're the same spots. So, but anyways, try to send a goal across the obstacles. Yeah. All right. So we see here that it has less trouble finding that spot than in the reality. Yeah, that's interesting. But the cost map is still incorrect. I don't know why it looks like this, but if you were to move an obstacle and put it in the middle, my bet is that it wouldn't avoid it. So that means that there's still some work to be done in there for the local cost map, which is basically just testing. Testing. And my guess with the trouble it was finding, either the recovery or the new path planning algorithm should be fine-tuned in order for it to not get stuck like we saw earlier. All right.
Yeah, it did change the inflation, the cost map inflation as well. I increased it so that it goes around, but that is what
What do
it
you
just
mean?
ended up being like the cost map, the inflation radius,
Goes around what?
so that the robot goes further around the obstacle.
Yeah. I mean, that makes sense. But we
But
didn't
that's
see
what it
that for
ended
some
up being
reason.
really inconsistent. So sometimes it would, or sometimes it would just go run like in the real robot, it would
Hmm.
go right through the obstacle.
That probably means it's a fine tuning adjustment, and the inability to see the global cost map in the real robot might actually influence this, but it's a misconfiguration issue here. Uh, so that would explain why sometimes it does it, sometimes it doesn't. But all right, this is the everything I wanted to check, Neil. So if you want, could you please just unshare your screen here so we can wrap up here? All right, awesome. So I really was really nice presentation. It shows that especially the safe to spot and the go to pose. I think you called it. Those two
Yeah.
programs were really nice, and it was because of what I mentioned. So a lot of people that have a Python background, uh, their go-to way of saving the spots and then reading them is just like a normal text file, right? So then they would use something with Python to go in and check a text file to then input those values in the in the in the client action call, right? So what
Yeah.
you did that I really liked is that you went a step further. I mean, I wouldn't say step further. You went the correct way and using ROS2 parameters. Why is that good? Because at the moment you launch them, you have all those parameters accessible that you can. That's what you're doing. You're doing the get parameter because you already did the correct YAML structure files so to first load them and then acquire them. So I saw the ROS underscore parameter, and then
Yeah.
kind of skip that, and then to get the parameter. That was definitely my favorite part to see, and that means you understand the concepts of ROS2 parameters and why they're important when building applications on top of really common and popular open source things like the nav2 stack. Uh, the one thing that I do think requires more work is the fine tuning of this local cost map because that was really strange. We shouldn't see it like that. We should see sort of the
Yeah, a
the
defined marking around the obstacles.
right. So we should
Right.
see what we see in the global cost map. But in addition, if I was to put my hand, or if the uh, the the obstacles were moved a little, you would see them in the local cost map, and they would continuously update. So maybe as an update with the cost maps. So that does require a little bit of extra work in order to be able first to see if we can avoid obstacles, and then if the problem of the inflation cost map is what's causing the stuck behavior, because we want to avoid that as much as possible, right? When we are doing nav2 and we send a goal that can't be reached, it should detect that and either tell you that, or replan until it can find it, because at the end of the day, that's the goal of nav2. But those are my comments, Neil. Other than that, it's a really really nice project. So I want to congratulate you, and yeah, that is it. That is it for us.
Thank you.
So congratulations, Neil, and
Thank you.
yeah. So let me just go back here to myself here, and yeah. So this is what you can do when you are when you finish our courses. You can come and present what you've learned in order to obtain a certificate from us and solidify your learnings. So I invite everyone that is watching to do what Neil did here and come and show your project and see how it handles itself on an actual real robot. And Neil, I just want to congratulate you one more time and thank you for coming out and taking the time to present your project. Thank you very much. All right, guys, that is it for us. So we'll see you guys for the next presentation in a little bit, actually. So everyone, bye-bye. All right, cool, Neil. We are done.